Hello, welcome back to Math 7 with Mr. Passon. Today we are covering Unit 5, Lesson 7, how we can use volume to solve problems. So in these problems, we're going to be dealing with stuff that has multiple steps, and determining the volume is just one step in the real world problems. So we're probably going to have to do something after. Let me go ahead and zoom out just a little bit, see if we can see the whole problem. So let's start reading this problem. The neighborhood swimming pool is the shape of a rectangular prism. The pool measures 30 feet in length and 18 feet in width and has a depth of 4 feet. There are 7 gallons of water in a cubic foot. How many gallons of water are in the swimming pool? There's an extra "the" in there. Alright, so we know the length, the width, the depth, and 7 gallons per cubic foot. And again, control period to get the exponent. I need to know the number of gallons. So, first thing we're going to do is we're going to find the volume, right, in cubic feet, then convert to gallons. All right, so that's going to be our process. Now, it's a rectangular prism, so the volume equals the area of the base times the height. Well, in our case, that's going to be the depth. So that is going to be 30 times 18 times 4. And that's going to be feet cubed, right? Then, well, to go from feet cubed, so let's go ahead and figure out what that is. But we're going to say, well, every foot cubed is 7 gallons, so we're going to have to multiply that answer by gallons. And we're going to watch about that conversion. So we get that our volume is 2,160 cubic feet. Now, 2,100, I did not, I put an extra thing in there, 2,160 cubic feet Now, when we're doing a conversion, we're often going to think about fractions. So I'm going to go ahead and put a fraction bar and another fraction bar and a multiplication in here. So we want to convert 2 gallons. So we're going to put gallons on top and we're going to put cubic feet on bottom. So 1 cubic foot is equal to 7 gallons. And I'm just going to multiply those together. Then my cubic feet cancel. This is how we do a unit conversion, right? So we need to take our 2,160 times 7. So this whole thing equals 15,120 gallons. And that is our final answer. Okay. So now let's look that over. Remember, we had 2 steps. So we had 2 steps there. First, we had to find the volume, and then we had to convert the volume to gallons. All right. Now we're going to do another one. A refrigerator box is in the shape of a rectangular prism again. It's 78 inches tall by 48 inches wide and 24 inches deep. How many cubic feet will the box hold? So we know the length, width, and height. So we know the length, the width, and the height in inches, and we want to know the cubic feet. So one thing we could do is we could convert everything to feet, then find volume. All right. Now there's another way to do it. We could find the volume and then convert from cubic inches to cubic feet. And we could talk about that one, but I don't like that one as much because there's really big numbers involved. So let's think about this. We've got 48 inches, and remember there are 12 inches per foot, so this is 4 feet. All right, 24 inches is 2 feet. And then 78 inches, ooh, this one's a little bit harder. So that's 72 inches is 6 feet. So this is 6 feet. And that's 72, so there's another 6 inches, which is 6.5 feet. Now our volume of a rectangular prism is, so our volume equals the area of the base. Control comma to make that a subscript, times our height, and our length and our width are our 2 and our 4. So we've got 2 times 4, that's our base, times our 6.5. 2.4 times 6.5. And we get that this equals 52 cubic feet. Oh, 52 cubic feet. Now, there is another way to do it, but we could have done it with inches. We could have done our very large number, and then we would have had to figure out how many cubic inches are in a cubic foot. Well, it's 12 by 12 by 12. So, there are 1,728 cubic inches in every cubic foot. So going the other way, we would have had a much bigger numbers to deal with. And while we're still probably going to do this on a calculator, I like to keep the numbers reasonable and something that sort of makes sense. And the smaller the numbers are, the easier it is for us to generally think about them. Okay? So, let's look at another problem. Oh. The fish tank shown at the right needs to be cleaned. The cleaning product instructions state that 3 drops should be put for every 140 cubic inches of water. How many drops should be used? So I know the length, width, and height. Oh, would need the H on width. And I also know the rate that I need 3 drops per 140 cubic inches. All right. Now, what I need to know is the number of drops. Now, we're going to set this one up a different way because it's still a conversion, but we're going to look at it as a proportion and see if that makes it a different way for you to do it. So first, let's find our volume. So find volume. Then use proportion to find the number of drops. Alright, so our volume is 14 times 9 times 10. Right? And that is 1,260 inches cubed, or cubic inches. Right? Now, we know that it is 3 drops over 140 gallons. Alright? And I can turn that into a fraction. Let me undo that part though. And then that's going to be the number of drops that we need. So again, here I'm doing drops over cubic inches. And we're looking for this missing piece, and this is going to be 1,260. So now how do I solve this equation? Well, I've got my proportion equation. To get rid of a division, I have to multiply. So I am going to multiply both sides by 1260. So I've got 3 times 1,260 all divided by 140, and that's going to equal x. So notice we used our proportion of drops over inches, or over cubic inches. Right? And then we just solve our equation. And that means that we need our x is 27 drops. Alright, so our solution is that we need 27 drops. Alright, I'm going to clear that out. One more. A layered birthday cake has 3 rectangular prism layers. So this is a rectangular prism, this is a rectangular prism, this is a rectangular prism. The base layer measures 8 by 10, and then each layer is 2 inches smaller in width and length. All the layers are 5 inches tall. What is the volume of the cake? So what are we going to do? We're going to find the volume of each layer. Well, I guess what we know bottom is 8 by 10. The next layer, the middle, is 6 by 8. And then the top is 4 by 6. Now, I suppose that could have actually been my work, because I did some thoughts there. So maybe that should have actually gone here. So my bottom is 8 by 10 by 5. Right? So we've got my length, my width, and my height. Now this one, the middle is 2 inches shorter in each direction. So the middle is, well, in these two directions, so it's 6 by 8, but still 5 inches tall. And the last layer, the top, is 4 by 6 by 5. So our volumes are 8 times 10 times 5. So that's 400. Not 100, 400. 6 times 8. Oh, would help if I just did that right. 6 times 8 times 5. and that's 240. And then 4 times 6 times 5, and that is going to equal 120. So we add those all up, and our total, and notice that I actually was kind of slick here, and I tried to line them up so I can just add them up straight down. I get 0, I get 6, and I get 7. So it's 760 cubic inches. So notice that there's often going to be a rate conversion. There's often going to be a way that you're going to break it down, but these problems are going to have multiple steps where often we're going to find the volume and then do something with that volume. Okay? So think about the strategies that you're going to use there, and that's going to take us through the problem. There is an assignment in Alex, so go ahead and complete that assignment, and then we will go over and we'll talk about this more in class. Have a good day.